Here goes with more science. Today on Norris Teaches Science, starring me, Mr. Norris. We're still talking about meteorology. And if you haven't watched the other stuff, please go watch those. But we're going to talk today about the atmosphere in humans. And so by the end of the video, you should say, I can discuss the effect humans have had on different atmospheric processes. So when we talk about how humans affect the atmosphere, one thing that comes to mind is something called air pollution. And so, what is air pollution? Air pollution is airborne particles and gases. And usually they are concentrated large enough to endanger the health of humans. So, you can see in this picture over here where some air pollution comes from. Some of it's from cities, from humans, some of it is naturally occurring, yes. But humans do send air pollution into the atmosphere. Now, some of that pollutants are called primary pollutants, and these are emitted directly from identifiable sources. So, where do they come from? Transportation of vehicles. When we combust fossil fuels, we're creating air pollution. Industrial processes, aerosols, and even burning of coal, they all produce primary pollutants into the atmosphere. Carbon dioxide, sulfuric oxide, nitric oxides, they're all going into the atmosphere and they're polluting it. Some of them are also like methane, but those come from cow farts. But some things are called secondary pollution or pollutants. These are not emitted directly into the air. They happen in the atmosphere through reactions that sometimes produces um, more ozone, which is good and bad. Sometimes it produces something like smog. Smog, if you've never seen it, you probably have. If you've seen a picture of, say, New York City or Los Angeles from a distance, it looks like it has a brown dome over it. That's smog. That's air pollution. Um, Now, pollution's effect on human health, it can cause chronic bronchitis, um, a lot of coughing, asthma, emphysema, and some pollutants can cause people to have lung cancer at the same time. But these pollutants sometimes can produce something called acid rain. And I kind of talked about acid rain in this earth science when we talked about weathering of rocks, because when acid rain can chemically weather rocks, but acid rain is rain that is more acidic than normal. So most rain has about a pH of 5.6. The pH is looking at a scale. It goes from 0 to 12, 14. It goes 0 to 14, and 0 to 6 is considered an acid. 7 is neutral, and anything above 7 is a base. So most rain is about a 5.6 normally, but acid rain means that it is less than that, means lower than 5.6, because the lower the number, the more acidic it is. So as of 2000, most acid rain measured about a 4.3 on the pH scale. Now, how does acid rain form? You have these gases in the atmosphere that have been emitted by primary pollutants like SO2 or nitric oxides, NOx. The X would represent 2 or 3, just depends. It combines with the water vapor in the atmosphere and it produces something called sulfuric acid or nitric acid. Then that is rained down on an area and it can cause problems. Now, usually it's downwind from large cities and factories because that's where the pollutants would come from. So it's not, and wind moves it downwind to a different area, usually over actual forest or lake bodies or something like that. So, what can it cause? Well, it can cause chemical weathering of structures. It can change the pH level of a river to make it more acidic, which means it can kill off aquatic plants or aquatic organisms. which means it can kill fish. If it rains over land, it can kill trees. And there have been seen where acid rain has caused some mutations in some aquatic organisms. So, how do we monitor air pollution? We got a couple laws out there that are monitoring them. In 1967, we had the Air Quality Act. In 1970, you had the Clean Air Act, trying to make sure that we don't pollute our air too much. In 1978, the United States banned CFCs. CFCs are chlorofluorocarbons, is their long name, so we're just going to go with CFCs. They were used in aerosol cans and refrigerants and stuff, but we noticed that CFCs, which is an aerosol, when it went into the atmosphere, it started to destroy the ozone layer, causing holes in it. There was actually a hole over Antarctica. And in 1980, they passed the Acid Precipitation Act to try to find a way to lower the amount of primary pollutants in the atmosphere so that we aren't causing too much acid rain. But how can humans monitor air pollution? One, we can start to develop some more clean energy sources so we're not constantly relying on fossil fuels for our energy. We could use electric or hybrid cars. Electric is a good idea, but the problem is technically you're still using fossil fuels through electricity. Hybrid cars use both electric and gasoline. We could also have strict emission control standards, and we can use pollution control devices. One of those is like scrubbers. Scrubbers are placed into smokestacks of factories so that they kind of clean the air before it goes into the atmosphere, so it's not releasing all the pollutants. But that's the end here. I hope you learned something today. And I just